So what I want to look at now is inverse hyperbolic trig functions, and they are right here. So real easy, y equals inverse hyperbolic sine of x is how you write it. The first graph here is the sine one, and so it kind of looks like a cube root of x actually. The second graph here, this is inverse hyperbolic tangent. Kind of looks like tangent, doesn't it? Y equals inverse hyperbolic tangent of x. But tangent goes between 1 and, pi over 2 and negative pi over 2. This goes between 1 and negative 1. All right, and so those are the graphs of them. Now the inverses of them, if you remember from the last video, hyperbolic sine of x has an e to the x expression in it. E to the x minus, that's all this, right? So since it involves e, we can rewrite the inverse hyperbolic sine of x using natural log, because it's going to be a natural log expression, okay? Because remember, the inverse of e to the x, so if f of x is e to the x, then f inverse of x is the natural log of x, and vice versa. They're inverses of each other. So if you have hyperbolic sine of x involving e to the x, the inverse hyperbolic sine will involve natural log. And so here they are. There's another misprint in the book. This should be inverse hyperbolic sine of x. I'll have to email them. So notice it has a natural log, and then all of them do. All of them do. All right. So I can prove that to you, or I can just walk through that with you in the book. All right, so here we are. Let's see what we got here. So I'm going to let y equals inverse hyperbolic tangent of x, and then so if I take the hyperbolic tangent of both sides, I get this right here. Now hyperbolic tangent is just e to the, it's sine over cosine, hyperbolic sine over cosine, so it's going to be e to the y minus e to the negative y over 2, and then over, so this would be the sine, and then over e to the y plus e to the negative y over 2, and then we flip and cancel, and we end up getting e to the y minus e to the negative y all over e to the y plus e to the negative y. All right, so now all of this is equal to the x. So now we're going to multiply both sides by the denominator there, and we get this right here. I just cross multiplied. Now I'll pull everything over, and we'll get 0. Okay, so I don't really like this e to the negative y business here. So what I'm going to do is I'm going to multiply everything by e to the y. And so remember, e to the y times e to the negative y, that will just be 1, because it's y minus y is 0. All right, so then we're going to get x e to the 2y minus e to the 2y plus x times 1 there plus 1 equals 0. All right, so now I'm going to pull out the e to the 2y. I get x minus 1. And I'm going to take these guys and move them. Well, let's see, yeah, I'll move them over. So I get negative and then x plus 1 on the other side. Now I divide, and I get negative x plus 1 over x minus 1 when I divide. Now I'm going to move the negative to the bottom so that that looks nicer. And so I get x plus 1 over 1 minus x. And to make that look a little more symmetric, I'm just going to make it into 1 plus x over 1 minus x. Now, if I take the natural log of both sides, this is e to the 2y. Natural log of both sides, I get on the right side, on the left side, I get just 2y, because if I take the natural log of e to the 2y comes down in front, and the natural log of e, this is equal to 1. So this is 2y equals 1 plus x over 1 minus x. And so y is equal to 1/2 times multiplied by 1/2 on both sides, 1 plus x over, oh wait, I took the natural log of both sides, so this is natural log here, right? So this is natural log of 1 plus x over 1 minus x, and there you have it. And y, remember y was what we said the tangent was. Y was inverse hyperbolic tangent of x. And so I replace that with it, and I'm done. So inverse hyperbolic tangent of x is 1/2 natural log of 1 plus x over 1 minus x. Now let's try the derivatives. So here we are. So these guys right here, these are the derivatives. And so it's going to be really important that you know these. So it's kind of hard to see them. I'm going to zoom out a little bit. The derivative of inverse hyperbolic sine of x is 1 over square root of 1 plus x squared. Remember, what's nice, this is the derivative. So remember, derivative of inverse sine of x is 1 over the square root of 1 minus x squared. So you see the symmetry here? Remember, so now we have inverse hyperbolic tangent of x. The derivative of it is 1 over 1 minus x squared. Well, the derivative of inverse tangent of x was 1 over 1 plus x squared. So they're almost the same here. Almost the same here. And these become really helpful in Cal 2. So let's derive one of them, and I'll do it really quickly. So we have this one here. We just proved this one. So let's derive this one up here. All right. So what I've done is I've already done it, and I'm just going to walk through it. All right. So the inverse hyperbolic tangent of x, when I take the derivative of it, I've got this natural log of u, natural log sitting in here, right? So I'm going to call it just u for a second, okay? So I'm going to take the derivative of that. So all of this I'm just calling u for just a second. All right, so I'm going to take the derivative of that. Now, the derivative of natural log is u prime over u. So when I do that, the u is 1 plus x over 1 minus x right here. And so u prime, this is, we have f on top and g on the bottom. Right, all this is g and all this is f. All right, so when I do the derivative, let you pause the video and walk through that, I get this here, and then I simplify it, and it becomes 2 over 1 minus x quantity squared. So now I'm going to pull over what I had here. So it's this piece here is the this right here, and then the u, this is u, so this is u prime, this is u on the bottom, and then the 1/2 in front, just like 1/2's in front there. All right, so now when I simplify that further, these two cancel, and I get, and then the 1 minus x and those two cancel, and I get 1 over 1 minus x times 1 plus x, and I get 1 over 1 minus x quantity squared. So inverse hyperbolic tangent of x prime is 1 over 1 minus x squared, like that.